A balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeters of gas per second. Find the rate at which the radius of the balloon increases when the radius is 15 centimeter. See here, it is given that it is mentioned the balloon is always remains in the shape of a sphere. Okay, and it inflated by pumping in 900 cubic centimeters of gas per second. 900 centimeter cube per second. That is, what does it mean? It is the volume of the sphere, okay, volume of the balloon, okay, that is 900, that is rate of change of volume, okay, with respect to time. For a second, the volume changes, okay, changes of volume is 900 cubic centimeter or centimeter cube, okay. So, what is given? dV by dt, okay, that is equal to, V is the volume of the sphere. So, dV by dt is equal to 900 centimeter cube per second. Okay. Now, what we have to find? Find the rate at which the radius of the balloon increases when the radius is 15 centimeter. So, what is the rate of change of radius with respect to time when the radius is, okay, particular measurement of radius when the radius is 15 centimeter, what is the rate of change of radius with respect to time, okay. So, how it increases, how much it is increasing, so that we have to find. So, here let's write the formula. V is equal to, that is volume of the sphere, V is equal to 4 by 3 pi r square, right, that is pi r cube, right, yes, 4 by 3 pi r cube. So, dV by dt, that is given, okay. So, dV, let's differentiate it with respect to t, okay, so that we can find dr by dt. What we have to find? Dr by dt, rate of change of radius with respect to time. Okay, dV by dt is equal to 4 by 3 into pi, that is constant. Next, derivative of r cube with respect to t. So, derivative of r cube is 3r square into derivative of r with respect to t, that is dr by dt. Now, let's substitute here. dV by dt is 900, that is equal to 4 by 3, it is 3 cancelled, right, okay, here 3 cancelled, so no need to write 3, so 4 pi into r square, when r is 15 centimeter, so r square is 225, okay, r is 15 centimeter, so otherwise I will write, okay, 15 square into dr by dt, that we have to find, okay. Then this implies, take these all things here, so 900 divided by 4 pi into 225, that is equal to dr by dt. That implies here 225, 4s are 900, 4 cancelled, okay. So, 1 by pi. So, dr by dt is equal to 1 by pi centimeter per second, okay. So, the radius is increasing at the rate of 1 by pi centimeter per second. Hence, radius is increasing at the rate of 1 by pi centimeter per second. It is the answer. A balloon which always remains spherical has a variable radius. Find the rate at which its volume is increasing with the radius when the latter is 10 centimeter. See, here it is mentioned that the balloon which is always remains in the shape of a sphere and having variable radius. That is, radius is not constant, radius is varying. Okay. And we have to find the rate of change of volume with respect to the radius. Okay, note it down. See, we have to find the rate of change of volume with respect to the radius. That is, find the rate at which its volume is increasing with the radius when the latter is 10 centimeter. Okay, when the radius, final radius is 10 centimeter, what is the rate of change of volume with respect to the radius? Okay, so first of all, let's write the formula. Volume V of the sphere, that is equal to 4 by 3 pi r cube. R is the radius of the sphere. So what we have to find? Here we have to find dV by dr, the rate of change of volume with respect to radius. So let's differentiate it with respect to r. dV by dr is equal to 4 by 3 pi is a constant into r cube with respect to r, right? So that is 3r square. That's all. Okay, because we are differentiating with respect to r. That is equal to 4 by 3 pi into 3 into what is r? When the final radius is 10 centimeter, so we have to find the rate of change of volume with respect to the radius when the final radius is 10 centimeter. Okay, that is 100, 10 square. Okay, so 4 by 3 cancelled. So 4 pi into 100, that is 400 volume, right? Centimeter cube per radius, so per centimeter. Okay, 400 centimeter cube per centimeter. So how the volume is increasing? The volume is increasing at the rate of 400 centimeter cube per second. Not 400, 400 into pi. Okay, pi is here. Okay, 400 pi centimeter cube per second. A ladder is 5 meter long, is leaning against a wall. The bottom of the ladder is pulled along the ground away from its wall at the rate of 2 centimeter per second. How fast its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall? See here, let's consider it is the wall and it is the ground and it is the ladder leaning against the wall. Okay, what are given? The ladder is 5 meter long, so length of the ladder is 5 meter. And next, what is given? The bottom of the ladder is pulled along the ground away from its wall at the rate of 2 centimeter per second. See, we know that when the ladder is pulled along the ground, see its height, its length is increasing, right? So let's take it x, it is y. Okay, so this x length, x is increasing, right? So that is given, this x is increasing at the rate of 2 centimeter per second. Okay, when this ladder is pulled along the ground. Okay, so here what is given? dx by dt. Rate of change of x with respect to time is 2 centimeter per second. Okay, now what we have to find? How fast is its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall? See here, we need to find, see how much that is rate of change of this y. We know that when this ladder is pulled along the ground, its height is decreasing, right? So how much it is decreasing? When the distance from the wall to the ladder is 4 meter. Okay, when it is 4 meter, what is how much it is decreasing? Okay, that is how much this y is decreasing. That is rate of change of y with respect to time. That we have to find when this length, that is distance between wall and the ladder is 4 meter. Okay, so we have to find dy by dt. dy by dt. Okay, since it is a right angle triangle, we have to apply, see we can apply Pythagoras theorem. Okay, so here it is given when it is x is equal to 4 meter, then what is y? X square plus by Pythagoras theorem, x square plus y square is equal to 25. Okay, therefore here we can find y value, right? That is y square is equal to 25 minus x square, that is 16, that is equal to 9. This implies y is equal to 3. Okay, when x is equal to 4 meter, y is equal to 3 meter. Okay. Now, what we have to find? dy by dt. Okay, let's write this equation again. X square plus y square is equal to 25. Okay. To find dy by dt, let's differentiate it with respect to t. Okay. That is 2x, next derivative of x with respect to t, dx by dt plus 2y. Okay, differentiating this equation with respect to t, dy by dt, 2x dx by dt plus 2y dy by dt is equal to derivative of constant is 0. Okay. Now, here you should be careful here. See, 2 into x, see our dx by dt is in centimeter. Okay. See here you should be careful about this unit also. Okay. Otherwise your answer will be wrong. Okay. So here 2 into x. See, let's convert this meter to centimeter. Okay. So it is given x is equal to 4 meter, means 400, because our dx by dt is in centimeter. Otherwise you can convert this centimeter to meter also. Okay. So we have to make all the units same. Okay. So here x is 4 meter, so 400 centimeter. See here I will write x is equal to 400 centimeter and y is equal to 300 centimeter. After that only substitute. Okay. 2 into 400 into dx by dt is 2 plus 2 into y is 300 into dy by dt, that is equal to 0. Okay. We need to find dy by dt, right? That is, it is correct. Okay. 2 into 400, that is 800 into 2, that is 1600. Okay. Plus it is 600 into dy by dt is equal to 0. Let's take this one right side. So dy by dt is equal to 1600 divided by 600, 0 cancelled. Then 2 3s are 2 8s are. Okay. 8 by 3, it is height, right? Okay. Centimeter. A centimeter per second. Okay. So therefore here it is minus, right? Yes, minus, because when we take this 1600 right side, it will be minus. Okay. So here we should get minus because it is decreasing, right? When this ladder pulling along the ground, so this height is decreasing. That means we should get it is minus. That is dy by dt should be in minus, right? Okay. So here we can say this height of the wall is decreasing. Height of the wall is decreasing when the length, that is when the foot of the ladder is 4 meter away from the wall. That is the height of the wall is decreasing at the rate of 8 by 3 centimeter per second. Okay. So we can write the height of the wall is decreasing at the rate of 8 by 3 centimeter per second, because since it is minus, we should say it is decreasing. Okay. So height of the wall is decreasing at the rate of 8 by 3 centimeter per second. Next question, a particle moves along the curve 6y is equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as x coordinate. See here, given equation of the curve is given. It's little different question, right? So a particle moves from the curve 6y is equal to x cube plus 2. Okay, equation of the curve is given and we have to find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. That means rate of change of y with respect to time, okay, as fast as, that means rate of change of y with respect to time is 8 times rate of change of x with respect to time. Okay, so here we have to find the values of x and y, points on the curve. Okay, so here, but first of all let's write equation of the curve. Given 6y is equal to 6y is equal to x cube plus 2. Okay. Then here let's differentiate it with respect to t, because it is given dy by dt is equal to 8 times dx by dt, right? So let's differentiate it with respect to t. So 6 dy by dt is equal to 3x square with respect to t, right? So 3x square into derivative of x with respect to t, dx by dt plus 0. Derivative of constant is 0. Okay. And what is the relation between them? See, it is given dy by dt is 8 times dx by dt. Okay, rate of change of y with respect to t is 8 times the rate of change of x with respect to t. That is, it is given dy by dt is equal to 8 times dx by dt. Okay. Now let's substitute this one in, let's take equation 1. Okay. Consider this as equation 1. So equation 1 gives, substitute dy by dt the value in equation 1. So 6 into 8 dx by dt is equal to 3x square dx by dt. Okay. See here dx by dt cancelled. So this implies here 3 cancelled, right? 2. So x square, we have got x square is equal to 16. That implies, see, x is equal to plus or minus 4, right? Plus 4 or minus 4. Okay, now according to this x value, we will find y value, substituting x value in the equation of the curve, right? So here equation of the curve is 6y is equal to x cube plus 2. So when x is equal to plus 4, 6y is equal to x cube, that is 4 cube, that is 64 plus 2, that is 66. So y is equal to 66 divided by 6, that is 11. Okay, and when x is equal to minus 4, 6y is equal to minus 4 whole cube is minus 64 plus 2, that is minus 62. So y is equal to minus 62 divided by 6, 2 3s are 231, right? So minus 31 divided by 3. So what are the points? The points are 4, 11 and minus 4 minus 31 by 3. Okay, these are the points on the curve. The radius of an air bubble is increasing at the rate of 1 by 2 centimeter per second. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? See, here it is given the rate of change of radius. We know that bubble is in the shape of a sphere, right? Okay, so the rate of change of radius with respect to time is 1 by 2 centimeter per second, right? So here we have to find volume of the bubble. See how much volume is increasing when the radius is 1 centimeter. Okay. So what is given? dr by dt. That is given. Rate of change of radius, that is radius is increasing at the rate of 1 by 2 centimeter per second, means rate of change of radius with respect to time, dr by dt is 1 by 2 centimeter per second. Okay. So what is the volume formula? Volume of the sphere is V is equal to 4 by 3 pi r cube. Okay, volume V is equal to 4 by 3 pi r cube. R is the radius of the sphere. Okay, now let's differentiate it with respect to t. We need to find dV by dt, that is rate of change of volume with respect to time. Okay, so dV by dt is equal to 4 by 3 pi is the constant, so 4 by 3 pi into derivative of 3 r cube is 3r square into derivative of r with respect to t, that is dr by dt. Okay, derivative of r cube is 3r square into derivative of r with respect to t, that is dr by dt. Okay, now let's substitute the values. 4 by 3 cancelled. Okay, 4 pi into r square, when r is 1 centimeter, so 1 square into dr by dt, that is 1 by 2. Okay, that is equal to 2 cancelled, so it is 2 pi. It is volume, right? So centimeter cube per second. Okay, so the volume is increasing. Volume is increasing at the rate of 2 pi centimeter cube per second. A balloon which always remains spherical has a variable diameter 3 by 2, 2x plus 1. Find the rate of change of its volume with respect to x. Okay. So it is given that it is mentioned the balloon which is always remains in the shape of sphere and its diameter is 3 by 2 into 2x plus 1. Okay. So diameter is 3 by 2 into 2x plus 1. So what is the radius? It's half, right? That is 1 by 2 into 3 by 2. 1 by 2 into 3 by 2, 2x plus 1. That is nothing but 3 by 4 into 2x plus 1. Okay. Now what we have to find? We have to find the rate of change of volume with respect to x. It is given directly, that is we have to find rate of change of volume with respect to x, that is dV by dx. So what is the formula? Volume of this sphere V is equal to 3 by 4, right? 4 by 3 pi r cube. Okay. Volume of the sphere V is equal to 4 by 3 pi r cube. And see here what is r? Let's substitute what is r. We have to find the dV by dx, right? We have to differentiate it with respect to x. So here let's substitute what is r. 4 by 3 pi 3 by 4 2x plus 1 whole cube. Okay, we have substituted r is equal to 3 by 4 2x plus 1. So that is equal to here 4 pi by 3 into 3 cube is 27 divided by 4 cube is 64 into 2x plus 1 whole cube. Okay, that is here 3 ones are 3 9, 4 ones are 4 16. So it will be 9 divided by 16 2x plus 1 whole cube, right? Pi. 9 pi divided by 16 into 2x plus 1 whole cube. Okay, now let's differentiate it with respect to x, because we need to find rate of change of volume with respect to x, that is dV by dx. Let's differentiate it with respect to x. So it is the constant. 9 pi divided by 16 is the constant. So let's differentiate it. So 3 into 2x plus 1 whole square, right? That is x cube. Derivative of x cube with respect to x is 3x square, right? So 3 2x plus 1 whole square into derivative of 2x plus 1. Derivative of 2x is 2. Derivative of 1 is 0. Okay. That is equal to here 9 pi into 6 2x plus 1 whole square divided by 16, right? So here 4 4 2 8s are 2 3s are, right? That is 27 pi divided by 8 into 2x plus 1 whole square. So it is the dV by dx, rate of change of volume with respect to x. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone increasing when the height is 4 centimeter? See here, we know that when we pouring sand from the pipe, so it forms a cone on the ground, right? Okay, and it is given that, see, its volume is 12 centimeter cube per second. Okay, that is its volume is increasing at the rate of 12 centimeter cube per second. So here we have to find, see, and it is conditions are given, see, in such a way that the height of the cone is always 1/6 of the radius of the base. That is here, okay, first of all let's write. So what is the formula? V is equal to 1 by 3 pi r square h, right? That is here what is given? V is given, that is dV by dt, rate of change of volume with respect to time, that is given, that is equal to 12 centimeter cube per second, since it is volume centimeter cube. Okay, now and next condition is, see, height of the cone is always 1/6 of the radius. So height is equal to 1/6 into r. Height h, radius r. Okay. So h is equal to 1/6 into r. That implies r is equal to 6h. Okay. Now let's substitute this r is equal to 6h in the equation. V is equal to 1/3 pi into 6h whole square into h. That is equal to 1/3 pi 36 into h cube. Okay. So here that is 36 h cube, 3 into 12. Okay. That is 12 pi h cube is the V. Okay. Now we have to find what? We have to find how fast is the height of the sand cone. See here how fast the height of this sand cone is increasing when the height is 4 centimeter. Its height is increasing, right? So how much it is increasing per second, that we have to find when the height is 4 centimeter. So we need to find rate of change of height with respect to time, that is dh by dt. So let's differentiate it with respect to x. Okay, dv by dt is equal to 12 pi into 3h square into dh by dt. That implies here 36 pi into h square. See what is h? When the height is 4 centimeter. So right, that is 16 into dh by dt. Right? So what is dv by dt? Here dv by dt is given. So 12 is equal to 36 pi into 16 into dh by dt. Okay. So 12 ones are 12, 3s are, right? Okay. That implies, see it is 3 into 16 is 48. So that implies 1 is equal to 48 pi dh by dt. We need to find dh by dt. So take dh by dt. Take this one here. Okay. So that implies, it implies dh by dt is equal to 1 divided by 48 pi. Okay. We have taken 48 pi left side. So it will be dh by dt is equal to 1 by 48 pi. See it is, since it is height centimeter per second. Okay. So the height of the cone is increasing at the rate of 1 by 48 pi when the height is 4 centimeter. Okay. So what is the rate of change of height when the height is 4 centimeter? 1 by 48 pi centimeter per second. The total cost C of x in rupees associated with the production of x units of an items is given by C of x is equal to 0.007 x cube minus 0.003 x square plus 15x plus 4000. Find the marginal cost when 17 units are produced. Okay. So here we have to find marginal cost when 17 units are produced. See here total cost is given, that is C of x is equal to, x is the unit. Okay. So C of x is equal to 0.007 x cube minus 0.003 x square plus 15x plus 4000. So here note it down. Marginal cost is nothing but that is the rate of change of total cost with respect to a unit. Okay. That is marginal cost. See marginal cost MC, that is equal to d by dx of C of x. Okay. That is equal to, so let's find the derivative. Okay. That is 3 into 0.007 minus, it is the C of x, into 2 into 0.003 x plus 15. Okay. Derivative of 4000 is 0. Okay. So here that is 21, 0.021 x square is there. Okay. 3 into 0.007 x square, it is x. Okay. Minus 0.006 x plus 15. Okay. Now it is here there are total 17 units. That means x is equal to 17. Okay. So we have to substitute x is equal to 17, 0.021 into 17 square minus 0.006 into 17 plus 15. That is equal to, here 17 square here 6.069. okay, 17 square into this is 6.069 minus it is 102, right, that is 0.102 plus 15, that will be 20.697. 697 is the marginal cost. So when 17 units are produced, the marginal cost is 20.697. Okay, so note it down. The marginal cost is rate of change of total cost with respect to a unit. Okay, so here the marginal cost is, here total 17 units are produced. Okay, therefore when 17 units are produced, the marginal cost is rupees 20.697. Similar question, the total revenue in rupees received from the sale of x units of a product is given by R of x is equal to 13x square plus 26x plus 15. Find the marginal revenue when x is equal to 7. Okay, see, last question was about, that is total cost. Okay, here there producing 17 units were produced, right? Here 7 units are sold. Okay, so here total revenue is given, so we have to find marginal revenue when 7 units are sold. Okay, so here also that is marginal revenue is nothing but rate of change of total revenue, okay, with respect to a unit. That is marginal revenue, that is equal to d by dx. So note it down. Marginal revenue is equal to rate of change of, that is d by dx of R of x. Okay, rate of change of total revenue with respect to a unit. Okay, so x is the unit here. Okay, so here that is d by dx of 13x square plus 26x plus 15. That is 26x, 13 into 2x, that is 26x plus 26. So this can be written as 26 is common. So 26 into x plus 1. Okay, so marginal revenue is 26 into x plus 1. What is x? So when 7 units are sold, okay, so x is equal to 7. That implies 26 into 7 plus 1, that is when x is equal to 7, MR is equal to 26 into 8, 20. Okay, so rupees 208. Okay, 208 rupees is the marginal revenue when 7 units are sold. Okay, when 7 units are sold, marginal revenue is equal to rupees 208. Look at the next question. The rate of change of the area of a circle with respect to its radius r at r is equal to 6 cm is options 10 pi, 12 pi, 8 pi, 11 pi. See here, area of the circle is A is equal to pi r square. Then here we have to find rate of change of area, that is with respect to its radius, dA by dr, that is equal to pi into 2r, that is 2 pi r, and dA by dr when r is equal to 6 centimeter is 2 pi into 6, that is 12 pi centimeter square. Okay, so 12 pi is the answer. 12 centimeter square per centimeter. Okay. The total revenue in rupees received from the sale of X units of a product is given by R of X is equal to 3x square plus 36x plus 5. The marginal revenue when X is equal to 15 is. X is the number of units. Okay, so when 15 units sold, okay, when 15 units sold, what is the marginal revenue? Okay, so here we know that marginal revenue is nothing but rate of change of total revenue, right? That is R of X, d by dx of R of X. That is d by dx of 3x square plus 36x plus 5. That is equal to 6x plus 36. That implies that is equal to, take 6 outside. So 6 into x plus 6, right? Okay, so when x is equal to 15, here 15 units are sold, okay. So we have to find the marginal revenue when 15 units are sold. When x is equal to 15, when x is equal to 15, marginal revenue is equal to 6 into 15 plus 6, that is equal to 6 into 21, that is 126, right? Okay, so rupees 126. So here rupees 126. 126 is the answer. Rupees 126 is the marginal revenue when 15 units are sold.